Hey, Kyle here with Maple Systems. Welcome to another Maple Systems video training series. Hey there, in this video I'm going to go over what a VLAN is and how you would manage it on your network using one of the Maple Systems switches, specifically one of the Lite-Managed switches. It is important to note that you can only manage a VLAN with a Lite-Managed network switch. In order to configure it, you will need a fully managed network switch, which Maple Systems does offer. That is the MS1M08G, and you can refer to the Managed Series Industrial Network Switch Operations Manual to get all the information on VLAN configuration for the fully managed industrial network switches. So first, let's understand what a VLAN is. A VLAN is a virtual local area network. It's technology used in networking to create logically separate networks within the same physical network infrastructure. So traditionally, it connects devices in a physical area, so all PCs on one floor of a building, for example. It lets you split that physical network into multiple virtual networks, even if the devices are in different locations. Devices on separate subnets cannot communicate with each other directly, despite being on the same physical network. And devices on different VLANs cannot communicate without a router or layer 3 switch. So why would you use a VLAN, or why would you need a VLAN? Well, security. You can separate certain sensitive systems like financial records or accounting from others that may be on a guest Wi-Fi. Traffic management. You can reduce unnecessary traffic by limiting broadcast domains. Finally, flexibility. You can group devices into separate departments rather than by location. So for example, in an office building, VLAN 10 may be the HR department, VLAN 20, IT department, VLAN 30 could be the guest Wi-Fi. So even if all these departments are plugged into the same switch, they cannot see or talk to each other unless you set up routing between them. Now let's go into MapleLink Lite and let's check out the VLAN configuration. So you want to sign into MapleLink Lite, log in. And to get to the VLAN, you want to go to security and then VLAN. And so here, port isolation. So port isolation, this is also called port-based VLANs. This lets you separate switch ports into their own private groups. So each port's traffic stops within its own group and cannot be sent to ports outside that group. So this works independently of VLAN tags, so it ignores any VLAN IDs in the packets. So port isolation is set up individually for each port by specifying its egress ports, which are down here, which are the ports it's allowed to send traffic to. So if the CPU port 0, which is the switch's management interface, is not set as an egress port down here, devices on that port will not be able to manage the switch. So to let two isolated ports communicate, you must add each one to the other's egress port list. So you would select the port here and add to the egress port list. By default, the CPU port is part of a VLAN with all Ethernet ports. So if a port is removed from this VLAN, you cannot manage the switch from that port. So you would select the port, one out of the 8 ports here, and then the egress ports are the outgoing ports to where the data packet leaves. So the V symbol here, the V indicates the port's packets that can be sent to that port. And then you would see a minus symbol or a negative symbol, which indicates the port's packets cannot be sent to that port. Now I mentioned the VLAN ID or the VID. Well, what is this? The VLAN ID, it's a number that identifies a virtual LAN. It's a 12-bit value, and it has 4,096 possible IDs. So 0 to 4,096. 0 is reserved for the priority tagged frames. Then 4,095 is reserved by the standard, which is IEEE 802.1Q standard, which I will cover later on. And then 4,094 are used for VLAN IDs. So I mentioned priority tagged frames. So what is a tagged versus untagged VLAN? So each switch port can process both tagged and untagged Ethernet frames. A tagged VLAN is a VLAN where the Ethernet frames include a 4-byte tag in the header. So the tag includes a VLAN ID plus other info like priority. Untagged has no tag in the frame, and it's used mainly on access ports for end devices. So here's an example of VLAN-based broadcast and multicast traffic containment. So for broadcast and multicast traffic, frames are only sent to ports in the same VLAN, so same VLAN ID, and never back out the port that they came in on. So this keeps traffic continued within its VLAN. And I mentioned I would go over what a 802.1q port-based VLAN is. Well, the devices themselves don't need to know about VLANs. They just work in their subnet. So the switch handles VLAN tagging and makes sure traffic stays within the VLAN, blocking any leaks between VLANs, and each switch port is permanently assigned to one VLAN. Any device plugged into that port becomes part of that VLAN and can only talk to devices in the same VLAN. So communication with other VLANs requires a layer 3 device, like a router, like I mentioned earlier. So this method is straightforward, fast, and easy to manage, especially when done in hardware using ASICs, which handle port to VLAN mapping at full speed without using the CPU. So back in MapleLink Lite, let's go to the VLAN tab here. So here are your 8 ports. Access, so you have your role column here. So access allows one VLAN only, which is an untagged port. It connects to a single device like a PC. And then you can also select trunk. And so the trunk port connects to another switch. It can carry traffic for up to 5 VLANs at the same time. Traffic is tagged with its VLAN ID. And by default, all ports join in on VLAN 1. And then the max amount of VLANs to configure on the device is 5. Finally, let's put this in a real-world scenario. Let's say a new technician plugs their laptop into a port near the control panel. So if the port security and VLANs are properly set, the port defaults to VLAN 20, which is the PLC, but the technician's device gets no access because only PLC devices have static MAC entries allowed on those ports. And unknown MACs are either blocked or moved to a guest VLAN with no access to the SCADA. A troubleshooting example, SCADA workstations are unable to talk to PLCs. So 1, you want to check that the SCADA workstations are on VLAN 30. 2, verify the default gateway is correct. Let's say you have an IP address of 192.168.30.1, and then do a test ping to that IP address, which is the PLC gateway. Ensure that the inter-VLAN routing is enabled. And then you want to check ACLs aren't blocking traffic between VLAN 30 and VLAN 20. And then in your command prompt, you can use show VLAN, show interface trunk, and show IP route to inspect. So the benefits that you achieve here in this scenario, so you have isolation of broadcast traffic, which reduces latency in SCADA systems. You have enhanced security posture by locking down inter-VLAN communication, improved troubleshooting and scalability for network teams, and regulatory compliance, which is the industrial cybersecurity standard. So a summary of this scenario: you have separate virtual LANs in an industrial automation setting. So you have one for your critical OT systems and your SCADA. Then you have another LAN for office IT systems, say laptops. Then you have security and voice for guests on unmanaged devices. So this design enhances security, stability, and performance, and allows future growth as the factory adds new production lines or upgrades control systems. Well, that wraps up this video tutorial. To get more information, you can visit the What is a VLAN and How to Manage It on Your Network tutorial page. And then also be sure to visit the Maple Systems Network Switches page, and this can all be found on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.